Hello guys, today I'm going to show you a three-tier architecture that is deployed using Java. So this will be our application. You have the deposit, withdraw, transfer money options. You can also check out your transaction history. So without further ado, let's get started with the project. So you can get over to this project repository. I'll provide a link of this repository in the description of the video. You'll have two branches, master and end branch. I want you to clone this repository and start working with the master branch. And for you guys, once you clone the repository, this is what you will have on the master branch. And I'll be working on the end branch. So by the time that the video ends, the completed project will be found on the end branch. Anytime you want to get help, you can check the end branch and also this video to to troubleshoot any errors that you're facing during this application deployment. So inside the project, I've given a MySQL script. All you need to do is create a database, file, new query tab, and you just basically uh, copy paste the script, and you will run the script, and that should create a database here. And creating the tables, all those things will be taken care by our JPA repository. So our project has Spring Boot JPA for performing CRUD operations in the database, security for the Spring Boot uh, security, Thymeleaf for the front end, Spring Boot starter web, and the Spring Boot Time Spring security. And since we are using MySQL database, I've used MySQL dependency. But if you are using Postgres, then make sure that you use Postgres dependency here. And this is our project. Inside this, we'll create packages. We'll create service package. We'll create repository package. We'll create a controller package. We'll create a model package, and we'll create a security config package. And we'll start coding from the model class. Yes, I'm in the end branch. So inside the account, we'll make this as entity, and our account will have these attributes, which is ID, then it will have a username, private string username, private string password, private big decimal balance. It should also have, yeah, to get rid of this thing, we need to mark our ID as the primary key, and we will leave Spring to take care of the auto increment of the identity values. And we also need a list of transaction by the user. A new transaction class will be created. I don't need this, not yet. We'll create a new transaction class. And we'll import the list. So one account will have many transactions, so we'll mark this as one to many and mapped by account. And we'll also have a private collection. Extends granted authority. We'll name this as authorities, and we'll name this as transient so that a column won't be created with this name authorities. And the next is we will, so I was just getting a call. Okay, so the next we will generate constructors, one for none, constructor for everything except the ID. And the next we will generate getters and setters for all the attributes. So with that, our transaction class is done. So now we'll code our transaction class. Our account class is done. So we'll have a private long ID. Then we'll have a private big decimal amount that will be transferred during the transaction. Then we'll have a private string of type. Then we'll have the time during when the transaction has been made. So we'll name it as timestamp. And our ID will be our primary key, identity, cool. And we'll also need an account. So many transactions will be linked to one account. So we'll mention that. Name will be account ID. And the next thing we will do is we'll create constructors. Select none and one for everything except ID. Then we'll also generate getters and setters for all the values. And now we'll code the repository layer. This will be account repository, new Java class. This will be a interface. And the same will create one for transaction. So our account repository will extend JPA repository, and inside the JPA repository we need to mention the name of the class that this is extending to. This account repository extends account class, so we mention that. And the next one we should mention is the type of the primary key. If we check the account, the type of the primary key is long, so we mention that here. It's long, it's of type long. And then inside here we will have one method. We do this as optional because we might not find a username with this username, so we specify this as optional. And for the transaction history we do the same thing. This one will extend JPA repository of the class transaction, and the primary key of transaction class is of type long, and this will return us a list of transaction find by account ID. So we'll take an account ID and we'll find all the transaction history of that account. And we can also annotate this with the repository layer. And the next thing that we will do is create service layer. So we'll name our service as account service. And yeah, all the codings that I'm doing here is done in the end branch, and you guys can start working with the master branch. So we will use a password encoder because the password encoder will help us encode the user typed password and store it in the database in an encoded format and not in plain text. So for that reason, we are using this class password encoder. It encodes the raw password into an encoded format, and we'll also need the repository layer. Account repository, and we'll have this as a private, and this is injection method, and we will do the same thing for the transaction history, transaction repository. Once that is done, we can create our methods inside the service layer. So one first method that we will create is to find an account by username. So for that, we'll use public account find account by username, and the string will be username. Return account repository is responsible for finding an account by username, so we'll use the account repository method for that. If it finds, good, but if it doesn't find, then we'll use the or else throw block. New runtime exception, account not found with the username. Yep, that's done. So find account by username method has been coded. The next method that we want our service class to be able to do is register account. So we'll create one, and the register account, it needs two things to register an account from the username. From the user. The user should pass his username and his password. Once it has the two, first thing we'll check if the username already exists. So we'll make use of the account repository dot find by username. If it is present, if it is present, if it is present, then we will throw a new exception, no new runtime exception. Account already exists with the username that the user is trying to register with. But if not, we will create a new account class which will take care of registering the new account for us. New account, and now account dot set username from the user. Account dot set password encoder will use the password encoder to encode the password that the user has provided. And account dot set balance big decimal dot zero, and we'll use the account repository to save this new user account. So with that being done, our registering the account is done. So next we will code up the deposit part. Deposit. So the deposit will take two things into account. One, which user is trying to deposit the money, which user account, and how much money he is trying to deposit. So first we will see if the so the we take the user account, and we are going to set the user account's balance by getting his current balance, then adding the amount that he is depositing. Once that is done, the account repository will save this amount, and also the transaction history will store this transaction, store the transaction. It will take the amount and the type, deposit, the time, local date dot time dot now, and the account, and also save it. The transaction repository will save this. Deposit is done, but the next we are going to code up is withdraw. You can only withdraw the money that you have in your account. If you have 1,000, you can withdraw 1,000, but not 1,001 or more than 1,000 rupees. So for that concept, we will first check if the account has enough balance. So get balance and compare it with the amount that the user is trying to withdraw. If the user is trying to withdraw more than he has, then we will raise an exception, insufficient balance. Your current balance is account.getBalance, but you are trying to withdraw this much amount. But if he has current amount of balance, then we will account.setBalance, account.getBalance minus the amount he has withdrawn. Then we will update this to the account repository dot save account. Also, let's update this in the transaction history. Transaction is equal to new transaction, and we need the amount, and the type is withdrawn and amount of amount, and we'll also mention the time. Excuse me for that. Is it recording? Oh, yes. Yeah. So that's done. Now we need the transaction repository to save this transaction for us. So yeah, deposit is done, withdraw is also done. And the next thing we will do is code up is the user details. User details, load user by username. We'll take the username here, username. If the username is not found, then we want this to throw a username not found exception. Okay, so this method has to implement user details service, and our account class should implement user details. So with that, let's code up this part. Count is equal to find account by username. We'll pass in the username, and if there is no account present with this username, then we will throw a new user not found exception. Username not found exception, account not found with the username. Yeah. But if the account was found, then we'll create variables string username of user is equal to account dot get username. String password of user is equal to account dot get password. See, it is not a good method to store this all in a variable, but I'm just doing it to explain you guys better in this video. Even better, I'll finish this, I'll code up this in a different way, but I'm just doing this so that you guys can get an idea of what is going on step by step. Account.get transactions. This will get all the transaction of the user, a list of transactions. Return new account. See, username of the user we are getting from here, account.get username, right? Because this this part, it has used the user detail class, and it gave us the username and all the username associated with the user account, and that's why we are using this. But to make this simpler, we are just gonna use the account.get username, account.get password, and account account.get balance. The transactions, account.get transactions, and authorities. So I'll just delete this up. Guess you guys would have understood it by now, because people who are learning to code can easily catch these things, because smart people I know. And yeah, I'm missing this block. Yeah, so we now need to create a method for this authorities. So we'll create a public collection extends granted authority. It has it has one method, so it's a functional interface granted authority, and we are overriding with our authorities. This will return us an arrays as list new simple granted authority of type user. Then the next thing we want to do is we'll create a new method for transfer amount. Transfer amount, and the transfer amount will need the sender account, and the string receiver username, and the amount being transferred, amount to transfer. Okay, now first we need to check if the sender who is sending the amount has enough money to send. For example, if he has 1,000 rupees in his account and he is trying to send 1,500, that's not possible because he doesn't have enough money. So in that case, we will throw new runtime exception. Runtime exception insufficient balance. Your current balance is sender account dot get balance. But you are trying to transfer. But if he has the enough money to make this transfer, then we will get the receiver account equal to find account by username. We'll pass this here. This will give us the receiver account object. Once we have the receiver account object, well and good. But what if we don't get the receiver account username? What if the user is trying to send the money to a user account that doesn't exist, or a username that doesn't exist? So in that case, we'll use an or else. Okay, we didn't use the account repository method here. Account repository dot find account by username. Find by username. Yeah, that's what it has. Find by username. If the username doesn't exist, then throw an exception. And the exception that I want this block to throw is uh, new runtime exception. Account not found with the username, receiver username. Yes, that's what I like about the paid version of IntelliJ Ultimate. Yeah. So if the user account exists, then we get a receiver account object, and using the receiver account object, we can send. Okay, let me make this easy for me to identify sender part. So the sender is sending money. So after he has sent the money, we want the sender account balance to be deducted. Sender account dot get balance, and subtract this money with the amount that he has transferred. And now by using account repository, we will save this money. And also we will update this in the transaction block. Before we do that, we will also update the receiver account dot set balance, receiver account dot get balance dot add amount to transfer, account repository dot save receiver account. Now let's deal with the transaction histories. Receiver. Okay. Now the transaction history for debit transaction. New transaction. Inside this, well, what do we need? Transaction. Inside the debit transaction, we need the amount, the type, the timestamp, and the account. Okay. So we need the amount. So the amount, the type is debit transaction, the time, and the uh, receiver account, sender account. Debited with money of. Debited with money of amount to transfer to receiver account dot get username. The current balances sender account dot get balance. debited with money of amount being sent to the receiver account. The current balances, yeah. And after that is done, we will save this transaction. For that, we will use the transaction repository dot save debit transaction. And the same we will do for credit. Credit transaction credited with money of from sender account dot get username. The current balance is receiver account dot get balance. Think, yeah, that, yeah, just because this small lines will just make it easier for us to look the code. Okay, so our service layer looks good. So details, and the final part we are going for the controller. We'll build up the controller now. We'll name the controller as bank controller, and inside the bank controller we'll first annotate this as controller. We need the account service class service, and we'll do method injection using auto wired annotation, and we'll use the get mapping. This will take us to the dashboard. Public string method dashboard. We'll use the model class model. Import this. UI.model. We need that interface. Add attribute. Yeah, this is what we need. So string username is equal to security context dot get authentication dot get name. This will give us the username, and with this username, see, Spring context holder is a part of Spring security. It stores the details about the current user's authentication session, and the get authentication dot get name will return the username of the currently logged in user. And with this details, account.account is equal to account service dot find account by username, and we'll pass the username, and we'll use model dot add attribute. This one has to be named as account. Why? Because that's how we have mentioned it inside our templates, the dashboard.html account. So it has to be accounts. You can't play with these keywords here, unfortunately. If you want to do, you can also change the templates thing. Then we will return the dashboard. And the next one we need to do is get mapping on the register page. Public string register account will need the request param, for get mapping now, because we simply have to return the registering page. So we'll do that. But yeah, when the user is trying to register, then he will use the post operation. So that time we will need those register, and inside this we will use a public string register. You know what? This makes sense if we name this as show registration form. Show registration form. Register account. This time the user will be trying to register an account using a username and a password. So we'll tell Spring that you can expect the user to give us two parameters, both of type string, the username and password, and we will also use the model class. And as usual, we'll use this part. First, with the try block, we'll see if the user account can be registered. Username, comma, password. Return redirect to login. To login page. After he has registered, he will be redirected to the login page. But if catch runtime exception E model dot add attribute error e dot get message, return the register page. Now let's code up the login page. Get mapping, show the user the login page. For that, we simply have to return the login page for the user. Return login. And the next thing we want to do is post mapping. We want, while the user is trying to deposit the money, use public string deposit. And this time the request param will be of type big decimal, as the user will be trying to send some money amount. And with this amount, first we need to find the username, because like I said, the security context holder is a part of Spring security. It stores details about the current user. So by getting the details about the current user, we'll use the account service and find account by username, and we'll pass the user details that the Spring context holder has returned to us. And with this details, we'll get hold of the user account by using the account service method, and from here we'll use the method account service find account by username. Then we'll use account service dot the deposit method. The deposit method needs the account and the amount. If you guys see here, the deposit method needs the account, an input of type account, and an amount. That's what we are doing here. And once this is done, we will return redirect to not the login page but the dashboard. And then the next post mapping will be for withdraw public string withdraw request param big decimal amount, and also we need the model. So to get all the user details, we will use the security context holder, and we will use the account service to get hold of the user account. First, we will try to account service dot withdraw account and amount. We are putting this around a try catch block and using model dot add attribute error e dot get message model dot add attribute account to the account, and this will return us the dashboard. If not, if this is successful, then we will return redirect to the dashboard. If it has an error, then the dashboard will give us this error on the dashboard. If there is no error, then we will just withdraw. I mean, like what happens here is the user is trying to withdraw. If the money is more than what he has in his account, then this catch block will be executed. And say, for example, if the user is trying to withdraw more money than he has, then the catch block will show that error message over here. Awesome. So the next thing we will do is we will do a get mapping on the transactions. Use public string, and the method name is transaction. Let's name it as transaction history. String username, we need the same thing, so we'll just take it from here. Oops. Then again we will surround this with the try catch block on service dot account service dot transfer amount. We need the type of account. Transaction history. Oops, we are dealing with the transaction history. So all we need is to get the transaction history of the user. Account.get transactions. Find account by username. Model attribute transactions account service dot. Yeah, we need to do the get transaction history, but I think we don't have a method in account service. Account service, a user details. Also, when we are using another one, when we are using a existing class, we are overriding the user details default class. And also we should have created here another method, public list type of transaction, and we will name this as get transaction history. This will take the account and account long account ID is equal to account.get ID, return transaction repository find account. Yeah, and with this method we can pass this account. Yep. And once that is done, we will return the transactions page. And the last part will be post mapping, transfer public string transfer amount, and it has request param string to username at request param big decimal how much money the user is trying to transfer, then the model. So we'll use these two same calls to get the user details, and we'll name this as sender account. We'll try surrounding this with a try catch block, count service dot transfer amount. Then we'll use the sender account. Then we'll use the to username, the amount. Catch runtime exception E, because yeah, this part will get details of the currently logged in user, and by getting the currently logged in user details, find account by username, currently logged in user's username, we get all the details of the currently logged in user who will be the sender account, and we pass that here sender account, receiver account, and the amount. Model dot add attribute, this will paste us the e-message, exception message, account, sender account. Return dashboard with the error message if there is something, or else give us the normal return direct message. And the last part of our application is to code up the config class. We'll name it as security config, and we'll annotate this configuration and enable web security, private account service, public static password encoder will return new bcrypt password encoder, and we will name this as a bean and this one as auto wired, and public security filter chain HTTP security HTTP throws exception. And inside this, first we will annotate this as a bean, and inside we will CSRF. So it's basically we are overriding the existing configurations of the HTTP security, the security filter chain. This method we are overriding these methods. Since everything that I'm doing here is a functional interface, I'm using lambda expressions to reduce the lines of code and override the settings. Dot request matchers register dot authorize HTTP odds dot dot permit all dot any request dot authenticated dot form login form form dot dot login page slash login dot login processing URL slash login default successful URL dashboard true permit all. So like I said, we are just overriding the HTTP settings. I will I will create a separate video for this, or else this one will become a lengthy one. Validate HTTP session true, and people might lose interest or take a big breaks while doing this project. So that's why I have decided to create a separate video on this part and patch requester. But for now, just all you need to know about this part is just think of this like the the security filter chain has some default methods, and we are overriding those settings to modify our application to be able to do the things that want our application to do. Headers header dot frame options dot same origin, and that's it. Once we have described all our settings, we will build the HTTP part, and at last we will create a method called configure global authentication manager builder. Authentication manager builder. We'll name this as auth. Can throw an exception. Auth dot user detail service, account service dot password encoder. Yep, and we will also auto wire this. So basically all our coding for our application has been done. So let me check this with the database. Let's try to run the application. Okay, the application is running on port 8080 on the path. Let me, and yeah, since it is already updated with my previously existing database, I'm able to log into the application, uh, make some deposits, like yeah, and transaction history, deposit of amount 300, time zone, back to dashboard. So yeah, we have successfully finished our project. So I'll push this code to the repository. You can find the completed code on the end branch. So yeah, one more time, thank you all for joining and watching this video. I hope I was able to teach something useful to you guys. I wish you all good luck and see you again. Bye bye. Bye. Thanks.